All right, so we're working on our CMP Patterns and Variables Investigation 1, problems 10 and 13. So I set up my heading on the top of the page with the title of what we're doing, the problem numbers, as well as my name, right? And then underneath I put number 10. So we're going to do 10, and then we're going to do 11 on the page underneath. So we'll start by reading 10. It says, make a table and a graph of time temperature data. So let's pull that phrase out. A table and graph, whoops, that's a really big highlighter. Let's shrink that down a little bit. A table and graph of time temperature data. So what that means is we're looking at a graph with time and temperature, and or a table with time and temperature. Okay. That fit the following information about a day on the road with the Ocean Bike Tours cyclists. And so it has 4 entries, entry 1, entry 2, entry 3, and entry 4. Well, let's read those 4 entries before we start doing anything else. Entry 1 says, we started riding at 8 a.m. The day was quite warm with dark clouds in the sky. Entry 2 says, about mid-morning, the temperature dropped quickly to 63 degrees, and there was a thunderstorm for about an hour. Entry 2. Entry 3 says, after the storm, the sky cleared and there was a warm breeze. Entry 4, as the day went on, the sun steadily warmed the air. When we reached our campground at 4, it was 89 degrees. Okay. So it says make a table and a graph of time temperature data. We're going to start with a table. So I'm going to go over here. And since it's time temperature, since that's what they told us, that means that time is going on the x-axis and temperature is going on the y, right? You know how we always do our ordered pairs in x, y order. So I'm going to make a table with time on one side and temperature on the other. We're going to make that a t-chart. Now keep in mind that you should be trying this on your own and then checking with what I have here. So if you haven't done it yet, go and do it, right? And then check with this. Otherwise, this isn't really helpful. You're just taking notes on what I do. All right. So we started riding at 8 a.m. and we reached our campground at 4 p.m. So I'm going to say that we're going to start our time at 8 a.m. and we're going to end at 4 p.m. So if I know that I'm going from 8 to 4, I'm going to give I'm going to just look at what are all the hours in between. So I'm going to increase my time by 1 hour at a time. So all the way from 8 to 4. So I'm going from 8 o'clock a.m. to 4 o'clock p.m. by 1 hour jumps, right? All right, so I've got one side of my table, and we're just looking at temperature now. So what my strategy is going to be is to take the temperature measurements that we have and fill those in right away. So for example, it says at mid-morning, the temperature was 63 degrees. It dropped quickly to 63 degrees. So mid-morning, I'm going to say, is 10 a.m. So we're going to call at 10 a.m., the temperature is 63 degrees Fahrenheit. All right, now the only other measurement that we know for sure is that at 4 p.m., temperature had increased to 89 degrees Fahrenheit. So those are 2 points that we have that we can put in our table, and we have to figure out what else can we add based on the entries that we have. So it says here that the day was started warm and the temperature dropped. So right here, I'm gonna point out that when they started riding at 8 a.m., the day was quite warm, and that the temperature dropped to 63 degrees at mid-morning. So that means it cooled down from being quite warm to 63 degrees. So I'm going to say quite warm to me, thinking like 75 maybe degrees Fahrenheit. And it says the temperature doesn't drop until 63, so I'm going to say it stays the same. So from 8 to 10, it's about 75 degrees, and then it drops to 10 to 63 degrees. And it says there's a thunderstorm for about an hour, so I'm going to assume that that temperature stays the same during the thunderstorm. Right, so right here, all we know is that it's quite warm in the morning, and then it drops quickly. And then here is this hour-long thunderstorm. So that's what I know. I know that it was quite warm. I know that it dropped quickly, and I know that we had an hour-long thunderstorm from 10 to 11. All right, so at noon, it says after the storm, the sky cleared and there was a warm breeze. So I'm going to assume that since there was a warm breeze from here to here, that the temperature is going to go up. So I'm going to say it goes back to 70. And then it says as the day, so that's entry 3. So we've done entry 1, we've done entry 2, we've done entry 3. So entry 4 says as the day went on, the sun steadily warmed the air until we got to the campground at 4 o'clock. So we know that the sun steadily warmed the air from 12 to 4. So it goes from 70 degrees to 89 degrees in about 4 hours. So I'm going to say that that's a difference of about 20 degrees, right? So if I'm looking at from here to here, it's about 20 degrees difference. So I'm going to, since it's 20 degrees over about 4 hours, I'm going to say that each jump is going to be about 5 degrees. So it goes from 70 to 75 to 80 to 85, and then it ends up at 89. All right, so we've got now a table of time and temperature data that shows what we know about the day, right? It starts quite warm, it drops quickly, it stays there for an hour, there's a warm breeze, so it goes from 63 to 70, and then the sun steadily warms the air all the way until 89 degrees at 4 o'clock. So we've got our temperature and time, our time and temperature data in a table. Now we're supposed to make a graph. Now making a graph from here, this is good practice, but this is one of those skills that we should feel pretty comfortable with. If you don't feel comfortable with this skill of turning a table into a graph, then you should probably email me and see what support I can give you, because this is one of those skills that we've been working on for a while. So we know that since it's time and temperature data, that the time is going to be on the x-axis and the temperature is going to be on the y. Right? And we also know that we have to go from 8 to 4 p.m., 8 a.m. to 4 p.m., and we have to go from 63 degrees to 89. So I'm going to, on the time axis, I'm going to say that let's call this starting point. First of all, let's bring this axis so it's on one of the grid. That makes more sense. I'm going to say that the starting time here is 8 a.m. We're going to do 9, 10, 11, 12. And then 1 p.m., 2, 3, 4. And since I have so much room, I'm actually going to spread this out, because that looks really that might be tough for us to read. So I'm going to spread this out. I'm going to make our graph go a lot further, and I'm actually going to make it so that every 2 lines is an hour. So 8, 9, 10, 11, 12, 1, 2, 3, and 4. Just a little bit more room for us to show what we're trying to show. You can do it every single line too if you'd like, but I like this way a little bit better. So on the other side, we have to go from 63 degrees to 89 degrees. So we pretty much have to go from 60 to 90. So what I'm going to do is I'm actually going to make this line here 60 degrees. And then I've got to go to 90. So I'm actually going to go by 5s. So I'm going to say each 2 lines is 5. So we're going to make this 65, 70, 75, 80, 85, 90. So now we've got our temperature from 60 degrees, which would be down here, right on the actual axis, all the way to 90, which would be up here. All right. So now we've got our graph set up. We just need to graph the points from our table. I'm going to do that in a different color just so that it makes it a little bit clearer. At 8 a.m. we know it's 75 degrees. At 9 we're saying it's the same. At 10 it's 63. So since it's between 60 and 65 and it's a little bit more than halfway, I'm going to go right about there. At 10 it stays the same. At 11 rather, at 12 it's up at 70 after that warm breeze. At 1 it's at 75. At 2 it's gone up to 80. At 3 it's gone up to 85, and at 4 it's all the way at 89 degrees. So we could also plot these as coordinate pairs, right, or value pairs. For example, this would be 489, or this would be 975, right? All right, so we've got our graph, and it asks us to make a graph. I think this is one of those questions where, I'm wondering, it's an interesting question to consider, to connect the dots or no, right? Does it make sense to connect the dots? I'm going to make the argument that it does, in the sense that there is some data that the problem gives us about how we might connect them, right? So, for example, that when there's a sudden thunderstorm, that the temperature goes down quickly, that there's a warm breeze that makes the temperature increase. But then also that since the temperature goes up steadily between this interval here, that we can pretty much connect the points with a straight line. Although there is a little bit of a difference, I suppose. Here the temperature goes up a little bit differently. All right, so this would be my graph and table for number 10. So I'm going to ask you to make sure that you try number 11 before checking out my solution for number 11. So if you need to pause here and go and try it for yourself, go do that. Don't just sit here and wait for me to do it for you, right? You're not going to learn anything that way. It's not going to help you, too, for when we actually are assessed on this, when we do work on Desmos with it. You need the practice, right? All right, so number 13. This is number 13, rather. I don't know why I said 11. There's part A, B, C, and D. We're going to start with A. So it asks us what the average speed for the whole trip is. So it gives us a whole data table. It says the following table shows time distance data from their bike tour from Williamsburg to Atlantic City. It goes all the way from 0 hours to 8 hours. They travel from 0 miles to 345 miles, right? So we know for our whole trip, our average speed, we have a way of calculating that. We know that it's distance, a ratio of distance to time. So how much distance did they travel divided by how much time, right? So it's a ratio that we can figure out by dividing. So average speed for the whole trip is going to be 345 miles divided by, or as a ratio to, 8 hours. So it's a ratio of miles per hour, right? So 345 miles divided by 8 hours. You can use a calculator to figure out what the exact number is. For our purposes, it makes sense to round here because we're just trying to practice, actually figuring out average speed, not practice dividing. But you get something like 43 and 125 thousandths, and this is in miles per hour, which, if we're checking for reasonableness, okay, it's a van going 43 miles an hour makes enough sense, I suppose. All right, and then B is asking us, what is the average speed for the first 4 hours? So we're doing 4 hours 0 to 4. Like we said, we know that average speed is equal to distance divided by time. So for our purposes, that would mean that speed is the speed for the first 4 hours is equal to the distance traveled in 4 hours, which is 200 miles, divided by the amount of hours in the first 4 hours, which is 4, right? And if we simplify that, we end up with 200 divided by 4, which is 50 miles per hour. For the first leg of the trip, which makes sense, right? A van going 50 miles an hour, not that surprising. So C says, what was the average speed for the second part of the trip? So let's go through and look. So I'm going to copy and paste pretty much most of this, right? I know that that's probably annoying. But we're doing the next 4 hours, so that's from hours 5, or rather from hours 4 to 8, right? So that's 4 hours. So our average speed is distance divided by time for the next 4 hours. So we know that the time that they traveled was 4 hours, right? Now for distance, it's a little tricky, right? It's not 345. We know that in the first 4 hours, they've traveled 200 miles, right? In the next 4 hours, they went from 200 to 345. So if we can subtract those and figure out that from here to here, from hour 4 to hour 8, they went 145 miles. So we don't want to put 345. That's the total number. We want to put the amount traveled in the 4 hours, which was, like we said, 145. So 145 miles in 4 hours. When we divide that, we do 145 divided by 4, which ends up being, again, don't have to be super exact, ends up being 36 and 25 hundredths miles per hour. There you go. So we have 50 miles an hour for the first part, 36.25 miles for the second part. So we can see that they traveled faster at the beginning than they did at the end. So question D is, I really like this question, but it is a little bit more complicated. So it says, suppose that the first 4 hours of the trip had traveled at a steady rate equal to the average speed. For the second 4 hours of the trip, suppose they traveled at a steady rate equal to the average speed in part C. Number 1 asks, can you sketch a time and distance graph that would result from this pattern of driving? And then it asks us to sketch a time speed graph. So this will be, I really like this question because it gets at what those graphs would look like. You really have to think about it. So it's really, the first part is asking us, can we do a time and distance graph time on the x-axis and distance on the y for the trip from 0 hours to 8 hours, right? So I'm just going to make every one of these grid lines worth an hour, and I'm actually going to do a couple things to fix this because I messed up already. I'm going to move these down so that 0 is the bottom and 8 is the 8th grid line. Oops. Also that I picked the wrong axis. All right. See, this is the kind of mistake that it would be nice to edit out of a video, but I'm not going to do that. So we're going to make every one of these grid lines on the time axis worth 1 hour. So going all the way from 0 hours to 8 hours. All right. Okay. So we have 0 to 8 hours on the time axis. On the distance axis, we have to go from 0 to 345. That's a lot. I'm going to make this 0 miles, and I'm going to make each one of these 50. So we'll call this 50, 100, 150, 200, 250, 300, and then 350. So those are our miles. So we have our time on the x-axis, our distance on the y, and we're just going to be graphing based on what we know. So there's a couple different ways you could do this. I prefer using the data table we have, right? So at 0, it's 0. So I'm just going to use that data table. At 1, it's 50. At 2, it's 110. At 3, it's 150. 4, it's 200. 5 is 220. 6 is 280. 7 is 315, and 8 is 340. So this leaves us with a graph that looks like this, right? So if we graph it the whole way, we end up with an actual time and distance graph based on our data table, right? Now, this is useful, but it's not what the question asks for, right? So we're going to have to draw a second one to actually answer the question. So the question doesn't ask us for a graph of time and distance for the actual data table. It asks us to take that and to turn it into a graph with constant speed, or with the speed staying the same. So I'll show you what I mean in a second. So in the first graph that we drew on the left over here, this one, we were actually drawing the distance that the van went at different times, right? And we see sometimes when the van went different speeds, right? Here, for example, it went a different speed as here, right? And we can tell because from 0 to 1 hours, it went 50 miles. From 4 to 5 hours, only went, I think, 20, right? So what they're asking us is, can we change this graph so that it shows the van going the same speed for the first 4 hours and the same speed for the next 4 hours? So how do we do that? There's a few different ways, but I'm going to show you one. So we know, I'm going to set this graph up the same way that I set up my last one, just going by intervals of 1 on the x-axis and the time axis, and then intervals of 50 on the y-axis. So time in hours and distance in miles. Cool. Okay. So if they want us to show constant speed, right? We're gonna have to draw the graph so that for the first 4 hours, it goes up by the same amount each hour, right? So we know that when it says steady rate, when it says steady rate, we know that that means it should go up the same amount each hour. It's going at a steady rate. So I'll show you one way that we can do that. In the first 4 hours, it goes from 0, right, at 0 hours, they've gone 0 miles. At 4 hours, they've gone 200 miles. And so if we want to show them traveling at the same speed, we can draw a straight line from 0 to 4, 200, right? So this is showing that they're going the same speed because every hour they're going up by the same amount of miles. So we can draw the beginning and end point and then draw a straight line between them. And we're going to do that again for the next part. So at 4 hours, they went 200 miles. At 8 hours, they went 345. And then we're going to draw a straight line to show that they're going the same speed. And now what we have is a graph where from 0 to 4 miles, they're going 50 miles per hour. And then from 4 to 8 miles, they're going about 36 miles per hour. All right. So that's the first part of first part of part D done. The second part is actually going to be less complicated. It seems like it would be more complicated, but it's going to be a little bit less complicated. So I'm going to actually keep this graph in the picture, this graph here in the picture, because we're going to use it to make our next graph. All right, so in this case, we're not looking for a graph of time versus distance, or time versus distance. We're looking for a graph of time versus speed. So I'm going to put time, right? Because in the question it says it's a time speed graph. So if this was a time distance graph, this is a time speed graph. All right, so we have time on one side and speed, time on the x-axis, speed on the y. So if we're trying to set up our graph, rather, we're going to set it up pretty much the same on the time, right? Just all the way from 0 to 8 hours. And on the speed side, we need to show 50 miles per hour and 36 miles per hour. So I'm going to say that we go up. There's 1, 2, 3, 4, 5, 6, 7, 8 grid lines. Let's be a little bit boring and just say that each grid line is worth 10. Not perfect, but it'll work. All right. So we've got a speed axis and a time axis, and what it's asking us to show is if they go a steady pace from 0 to 4, and if they go a steady pace from 4 to 8, how could we show that on a speed versus time graph? So I'm going to look at this graph here that we have already drawn, and I'm going to use that. So at time 0, they're going 50 miles an hour. At time 1, they're still going 50 miles an hour. So you can kind of imagine that I'm taking this data from the points on this graph, right? That from 0 to 4, they're still traveling 50 miles per hour. But that after 4 hours, they're traveling a different speed, right? So if I take this data and extend it down, at time 5, at 5 hours, they're not going 50 miles an hour anymore, they're going 36. So I'm going to draw a line down and say they're going about 36 miles an hour. And I know that that speed will stay the same for the rest of the trip, right? Because it's this whole thing, they're going 36 miles per hour. All right. So we have a graph now of their speed at different times, right? So for example, we can look at this graph and say at 3 hours, they're going 50 miles an hour, right? That's what those points tell us, right? So a point like 350 tells us at 3 hours, they're going 50 miles per hour. And we can connect the dots on here if we'd like to show different things, right? So for example, if they suddenly stopped and went and and decided and just they hit a different speed limit or something, they need to go a different speed, you could show the graph going straight down to show that they're slowing down immediately, right? That would show us that. Or you could connect the dots differently to say, well, maybe from hour 4 to hour 5 they slow down from 50 miles an hour to 36 and it's kind of slower, right? This would say they're going kind of slower for a while, slower for a while, slower for a while, and then they end up at 36. So, all right, so that's what I would do for part D, which is a great question and one that's going to help us a lot as we go forward, but is a little bit tricky. So don't hesitate to ask questions or try or go back and watch the video again and try it for yourself. We're going to get some more practice questions like this on Desmos, but in the meantime, if you have any questions, as always, shoot me an email. This is not easy, right, learning like this, but we're going to make it work, so let me know how I can help. All right, thanks, guys.